Went from here to here real quick. Okay, so let's take a look. What'd you guys get?
F of x minus f of h over x minus h.
Okay, that works. What was it? F of what again?
X.
X.
Who gave you that?
F of x
Minus f of h.
minus f of h
Over x minus h.
over x minus h.
There's also f of x plus h minus f of x.
Yeah, there's a lot of different ways to express this. What was the next one? X plus
Change
h?
in y over change in x
Uh-huh. And this here would be what?
over h.
Uh-huh.
And you put
So
the limit in front
I'll
of
put
it.
or, that's true. Or simply say yes. There's a lot of different ways to express it.
Or you could write x1 minus y1 over x2 minus. No, you're really never mind, ignore all previous comments.
Okay. All right, good. Nice warm
I
up.
could have just wrote change in y over change in x.
So where we left off on homework, what I want to do, I want to answer the question today. How do I estimate the velocity of a moving body given points of its position at different times?
Hope for the best.
Hope for the best. Did someone say questions? No? How do I?
And then I shook my leg just to like my sister things across the room and tried to land it on the trash can, but if we missed, we had to go pick up all the trash around the room. My leg feels like it's falling off. I need to go to the doctor.
All right, so here's the question. How do I estimate the velocity of a moving body given points of its position at different times? So this is actually where we left off looking at the homework. Looking at number 6, I believe is where we left off. We've completely finished 3.
Yeah.
Did we? I don't think we did actually. We left off at find the instantaneous rate of change of the area with respect to a side. Evaluate the rate of change of A at x equals 2 and s equals 10. Does anyone need to see the rest of that one? It's okay if anyone wants to. More than happy to. And if s is measured in inches and a is measured in square inches, what units would be appropriate for dA over ds? I'll tell you the answers at least. So
Inches squared over inch.
very good. For part C, to evaluate the rate of change of A at s equals 2, we have root 3 for our answer. And to evaluate the rate of change at s equals 10, we should have 5 root 3. No one get any different? No, everyone's good?
6 is lower.
I'm assuming we're okay on this so far, okay? And then anyone have any questions about part D as to why it's square inches over inches? No? Everyone feels good about that? Because the way we want to read that is square inches per inch. Okay? Change in square inches per change in inch is probably a more precise way to say that. And now let's take a look at 6, the weird one, we might say. I think for a lot of people this is when it gets kind of strange. We're given raw data and trying to answer this question here. So, number 6 says that we are given some points of an object's position. Okay? We're given its position because we're using S of t. Typically they use that for position. Again, I don't know, it's probably a Greek thing or something as to why the letter S is used for position. So we have t, which is in seconds. We have that written along S, which is in feet. Again, this is problem number 6 on page 135. All right, let's complete this. Yes? I thought I heard Mr. Gross, I'm sorry. S is in feet, and we have something occurring. We have data for at 0 seconds. It looks like every half second, all the way up to 4 seconds. So I'm running in a room here. Uh-oh. Oh no. I can cram it in here. I can cram it better than that. 0, 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, and 4.0. And the directions say, assuming that this smooth curve represents, part A, plot S versus T on coordinate paper and sketch a smooth curve through the given point. So that's the first thing we have to do after I'm done writing down the information. So we have 3.5, -4, -8.5, -10, -8.5, -4, 3.5, 14, I kind of jumped up pretty quickly, 27.5. Anyone concerned or not totally familiar with why there's some negative values in here?
Wait. I know, I have to say that. I don't kind of there.
So the reason that these can be negative, we're talking about position, is relative to a certain point. Now keep in mind, this is, I think it's moving along a line, it says here. The coordinates of S, a moving body for various values of T, and sketch smooth curve. So we're going to assume that it's just a moving body, and we're looking just measuring in one dimension here. So this means that, say, 3.5 feet in its position from some point in space. And then -4, that implies direction. So for those of you that have had the opportunity to take physics, you probably have a good understanding. For those of you who haven't, just keep in mind it's all relative. Like this is negative, let's say this is 4 units to the left of the starting point. And this is 3.5 units to the right. When in fact, actually this would actually be the starting point. So we define some point as, say, 0. Yes?
Can we consider this like a circle almost?
It really doesn't specify. It doesn't specify. It just says in exercises 5 and 6, the coordinates S of a moving body for various values of T are given. That's all we know.
Something like this.
We actually don't know what the shape of it is, but they're only giving us one little value. They're only giving us one coordinate, 3.5. Okay. So a simple way to think about this is well, we only have information in one dimension, so I'm only going to be concerned in one dimension because that's the information I have. So I think about this, and I think about, say, they call this like the point of 0, for example. Okay, but this guy actually started at 3.5, and then after a half a second, this particle or whatever it is, some moving body, ended up at -4. And that was after just half a second. That is pretty fast, right? It goes from 3.5 feet to the right at some point to -4 feet, to 4 feet to the left of that point in half a second. So this is a very quickly moving body. And then also it kind of jumps around. Well, sorry, it goes down because it says it's smooth. It actually looks like it's going down, and then it increases again. So imagine this thing is doing this. Now, right? Now what we're going to plot is actually we're going to plot S versus T. So let's go ahead and do that.
Did they make us graph on the calc exam?
I don't believe they made you graph, but I think you, not really. But there are free response answers, so theoretically, to support your answer, you could provide a graph. But I cannot recall, of all the ones that I've looked at, I cannot recall graphing something like on an XY plane. So anyway, you end up justifying your answers using some sort of theorem. No, I don't think there's any proofs. I don't remember seeing any proofs. I didn't see any proofs. I know, that's awful. I thought the same thing.
I guess we think.
No, I can use pink.
Can you use pink?
Pink is good. Now, I need to fit 27.5.
Why don't you make
So what does it, because you don't want to start graphing something like, oh crud, I have no room. Right, so look at here.
I mean, I think we have a pretty good idea of what the graph looks like, because it's gonna look like a thing of a.
A thingamabobber?
Well, it's gonna look like a parabola with one really long side.
Now, let's also understand this.
Yeah, you only need quadrant 1 and quadrant 4, right? Because you can't make.
Oh, okay, all right, we don't want to make a time, so that's good. We can do that. Good, I like that idea. We don't have to worry about that. I like that. Great. Beautiful.
And you only need to be able to go down like
Right, I only have to go down to -10, but as high as 27.5, so I'd probably lower this guy a little bit.
If you make them like 5, well, yeah, see, that's.
That might work.
That's
Okay.
not.
That works. I like that. So we are plotting S, if I can write. We are plotting, this is S, which is in feet versus T. So, plot S versus T. That implies that T is the independent and S is the dependent. Plot S versus T. Chatty Cathy today.
No, wait.
Every day.
I did it the wrong way.
Oh, okay.
I looked at the wrong way. Like I read it.
Let's try to focus, and I'd appreciate it.
So she hates me.
This is an S, that's a T. And I feel like going with pink today.
Yes!
Okay.
See, wait, whoa.
So we have, what's, whoa, what have
It's
I
not
done?
seconds versus feet, it's S versus T, which is
S stands in for feet.
because
Okay,
S
so
is
again,
S over T.
what I said
So
earlier
already went over this.
is typically they use the letter S to represent the position function. It's probably a Greek thing, if not some other
Okay.
besides the United States. Somewhere outside, somewhere else, okay? So just know, be comfortable, S of T is very typical to use position, and we've actually have used that before in a previous class. Let's go ahead and plot some points here. So we have when at 0 seconds, this thing starts at 3.5. Now I want to make sure I fit this thing. So I'm probably going to make a delta of 5, 10, 15, no, that's too much. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. I'm going to do 2. I'm going to do 2. And it's important that you, of course, label whatever you're doing. This is S. This is T. And now for this, it's only going to go up to, there's too much. You guys talking while I'm talking. If you have a question, I'd be glad to answer it, but otherwise, please don't. So we have to go from 0 to 4, and we only have 8 possible things from 0 or 9. So 1, 2, 3, 4, 5, 6, 7, yeah, 9. So we could probably space this one out pretty nicely here. Of course, we'll keep 0, 0, of course, but then we'll go increments of, say, I don't know, 4. That might work. And 2 is good. We'll say this is 0.5. But I gotta be careful though, it's gonna go down, isn't it? Yeah, there's some negative values. It's 0.5.
Thanks. It's my math.
1, 1.5, 2, 2.5, I'm so sorry, 3, what looks like a 7? Oh, this?
The 1.
Yeah.
The 1.
Well, you'll figure it out. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. More cram than I wanted. Darn.
Well, why don't you move it?
I really want to.
Do it.
You want to say it's like a challenge. Can I only select that, and then if I stretch it, oh my god, can I do it?
Oh my
Yeah,
gosh.
it should work.
That guy's stuck. That guy's just fixed at his point though.
But that's good. We want that, don't we?
My cat's stretching. No, my dog's stretching.
Right there, right there. So do that right there. Wait, what? No, where are you going?
Every fourth. Something about dividing thirds is killing me. It doesn't matter. It doesn't matter.
You'll still get a similar graph no matter where they are.
Yeah, at least it will be similar.
It's going to be the similar shape.
1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, that works. Whoa. Whoa. All right, here we go. Lots of points. When 0 seconds, we have 3.5. Something like that, huh? Uh-huh. I go a little bit bigger. And then we have at 0.5 seconds, it is at -4 feet. Right here. And then at 1 second, it's -8.5. 2, 4, 6, 8.5. Then at 1.5 seconds, it's at -10. 2, 4, 6, 8, 10. Uh-oh, is that not right?
It's
2, 4, 6, 8.
It's
9 would be right there, so it's got to be moved up just a skosh, yes? It'd be 8.5, huh? Right there? That'd be right? Okay.
And then the other, can you copy it? Because you can just like move it over. Never mind.
And then 2, we're at -8.5 again.
Yeah.
This should be in line with that guy. 2, 4, 6, 8, 9 would be halfway, so halfway to halfway. And then we have 2.5 at -4. And then we have at 3 goes up to 3.5. Right now. And then at 3.5 it goes to 14. 2, 4, 6, 8, 10, 12, 14. And then finally at the 4 second mark, its position is 27.5 feet. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, right here. And they want 27.5, which is like right here, halfway to halfway between that. So it does look pretty nice and smooth. Yeah? Plot S versus C on coordinate paper and sketch a smooth curve through the given points.
Describe your graph. It's a Nike symbol.
That actually works though.
Sounds logical to me because the Nike symbol has been the same for many, many years. I think since the beginning.
Didn't they take that?
I know the guy that suggested the idea.
If we have to do inequalities on the
Of just
top
doing- just
exam,
leaving this.
right,
Is that-
if we have to do inequalities on the top exam, I'm gonna make it dry gator mouth.
Yep.
Just put that out there.
Inequalities?
Yeah, I'm gonna be putting like two
Okay.
in the whole, like, it's gonna look awesome.
Let's not do that. All right, so did anyone get a graph that looks different than this one? Besides, of course, dipping on the delta you set for the blocks, squeezing, stretching. Didn't have enough room? Okay. So definitely what keeps these in hand, what makes it safe is to make sure that we are careful with enough room to work with. You know? Okay, so we did that. Okay. Assuming that this smooth curve represents the motion of the body, estimate the velocity at t equals 1 second, t equals 2.5 seconds, and t equals 3.5 seconds. So if you look at our data, we don't have anything for, well, we do have something at 1, but we don't actually have the function. We don't actually have the function written out. So what we'd have to do is pick values just to the left and right of 1 to estimate it.
Wait, what is it exactly asking us to do?
What it's exactly asking us is basically saying, do a very small increment to find for the average rate of change, use that as an estimate for the instantaneous.
Now, isn't that just time divided by distance? Isn't that velocity?
Well, average velocity, to be more specific, is the change in position over change in time, which is exactly what we'll be doing.
So, for those 3 values, so we would have to find
An equation or an expression and then find the derivative and then plug in those numbers?
And are you asking, do we have to develop a function?
yes.
No, we don't. That's not how they want us to do this. Nor on the AP Calc exam. That's not how you would do it. So I'm going to go ahead and do this. So in order for us to estimate, so we want to find f prime of s when, sorry, I got them confused again, right? T, yeah? Thank you. F prime of t when t equals 1 second, 1.0. That's what it's asking for that at t. It says, assuming that the smooth curve resists the motion of the body, estimate the velocity at t equals 1.0. Okay.
Take the 2 around it and then do the
So f prime of 1.0 is going to be approximately equal to, we're going to look at this and I see, okay, I know 1.5 and 0.5, those 2 points. So we're going to do the average. So f of 1.5 minus, I should have been using s to be consistent, just to keep it clear. Let's keep it clear. Let's make it s. Sorry to make you guys erase if you wrote f. Do forgive. S of 1.5 minus S of 0.5.
Wait, why are you doing that?
All over. And I know that you may decide to pick a different point. So we wanted to find R prime of 4. They chose 2 values to the right. Minus.
You get the instantaneous when you plug in a point, but the equation itself is the average.
Okay. So I hear a conversation. What's the question? Yes.
Alright, so I get this is average rate of change, but is S of prime standing for essentially like a derivative, or is it just another representing another function?
What this means is the first derivative of S of t.
But the derivative doesn't find the average rate of change; it finds the instantaneous rate
correct.
of change. So
That's
how
correct.
can we use that equation to find the instant rate of change at 1.0?
Well, we can use this expression here to estimate it, because we don't know the function.
So we're essentially using a secant thing going on here.
Absolutely. This is going to be the slope of the secant line from t equals 0.5 to t equals 1.5.
So it's like an estimated derivative in a way.
It is a way for us to estimate the velocity at 1 second. Yeah.
Thanks.
And that is how you would also approach that for 2.5 and 3.5. So if we did this, it would approximately be S of 1.5
If
was.
you just read it, you don't actually find it. Because you can't.
You can't. So this is what you would do. This is what you would do. Yeah. And this
Because you don't have
is.
the function of S.
I was actually found basically almost exact problem in the AP Calc practice exam, and this is exactly how they did it. So I want you guys to know this is what they expect on the AP Calc exam. It's not like you might look at this information And you might think, well, why can't we just use, if you want to know how it is at 1, why couldn't we use 1 and 1.5? Because they're close, just like these two are kind of close, but what you need to do is the two that are around it. That's what they want you to do, to use those 2 points around it, to estimate S prime 1.0.
If you were to plug in those values, you would get out the negative 8.5.
Okay.
Your S 1.5 is negative 10. You know what I mean? When you were to solve all this out, wouldn't you end up with negative 8.5? Is that what you get?
Let's see what we get.
Oh,
minus negative 4, which is negative 6.
And this is approximately negative 10 plus 4, so we get negative 6.
So that's the approximate slope.
Well, let's
for a tangent of
this
one,
is
right?
this is the approximate velocity of this moving body at the 1 second mark.
Because we're not, okay. Yeah, okay. Good.
Yeah, because you know, remember that velocity.
You plug in the points with this.
Mm-hmm. Yep. So we're using the 2 points that are around what we're doing, the point we're interested in.
And that is like constant for every problem that is like this. Like you use the 2 points.
That's what they're demonstrating on the AP Calc. Yep.
Well,
Is what an X.
so that's approximately. Looks like an
Negative 6.
I know, they look like an
It looks like you're the top part of an X and you grab to the bottom half.
And what would the units be?
It would be negative 6.
Feet per second per feet? 8%. Feet per second.
Yeah.
Oh, I bet you wanted that.
This is all it is.
Let's not talk about food. Let's not talk about food yet.
I'm in
For those, and did you guys raise your hand if this is how you did it? Really? You picked the 2 points around it? Very nice. Yes, you may.
I have a question.
Yes.
Is it going to be the same for 2.5 and 3.5? Negative 6.
So if we can complete this and we get 2.5, we are going to get, let's see, if we did at 2.5, I would do S of 3 minus S of 2. So 3.5 minus negative 8.5, which is 3.5 plus 1, which is 12. 12 divided by 1 is 1, so you'd actually have 12 for part B. So the answer to part B is 12 feet per second. And the answer to the third part of part B, which is at t equals 3.5 seconds, I would do S of 4 minus S of 3 over 27.5 minus 3.5.
So, but it's
Sorry, I started wrong. S of 4 is 27.5, so 27.5 minus 3.5, which is 24, divided by 1, which is 24.
But it's the same process for every single
Yep,
thing, right?
yep. So the last one would be 24 feet per second. And does that make sense? Does the rate of change increase as we go? Yeah, it does. Because if I took tangent lines, do you see that the slope of these tangent lines is increasing? So it does make sense based on what we got for the 3 parts to be.
Yes.
Okay?
You really draw very nice tangent lines.
Thank you. Practice makes perfect. So, see if we have time. What do we want to do for the last few minutes? Go on 11:15.
Chill.
Just chill.
Thursday's chill day.
Go ahead and do, with your partner, go ahead and do 5.
I don't like it though.
Go ahead and do 5. Or solo if you're solo.
Do you want to
I'll walk around and help if you get lost. But go ahead and do 5. See what we get.
Do you have to graph it? Because that's a big graph.